So, imagine this. You're sitting at your desk, scrolling through your phone, and suddenly, a headline pops up that says something like 700,000-year-old fossils change human evolution forever. Now, that's not just another clickbait story. It's a real scientific breakthrough that has scientists everywhere scratching their heads and rethinking everything they thought they knew about human history. These fossils, discovered in some remote corner of the world, are older than we ever imagined, and they're rewriting the timeline of our species' evolution. These ancient bones weren't just any old remains. They were part of a hominin species that lived way earlier than previously believed. Think about it. 700,000 years is like going back to when the first humans were still figuring out how to use fire and maybe even how to make tools. These fossils are like time capsules, giving us a glimpse into a world where our ancestors were just starting to walk upright and develop the complex social structures that would eventually lead to modern humans. But here's the kicker. These fossils don't fit neatly into any existing human family tree. They're not exactly like Neanderthals or Denisovans, nor are they quite like Homo sapiens. Instead, they represent a completely new branch of our evolutionary story, one that challenges long-held theories and forces scientists to ask questions like, who were these people? And how did they fit into the bigger picture of human evolution? This discovery is not just about finding old bones. It's about redefining what we think we know. It's like discovering a new chapter in an ancient book that you thought was already complete. Scientists are now racing to analyze these fossils, compare them with other finds, and piece together the puzzle of how our species evolved over millions of years. And honestly, this is just the beginning. There's so much more to uncover. So, if you're ready for a journey through time, where ancient bones challenge everything we thought we knew about human evolution, then buckle up. This isn't just another story. It's a revolution in science that could change how we see ourselves and our place in the world. Fossils are like nature's time capsules, frozen snapshots of ancient life that have been preserved in rock for millions of years. Imagine if you could open a box and find a perfectly preserved dinosaur or early human ancestor inside. Well, that's essentially what fossils are. They form when the remains of plants, animals, or even microscopic organisms get buried under layers of sediment, and over time, minerals replace the organic material, turning them into stone. This process is called fossilization, and it's a bit like nature's way of saying, hey, I want to remember you. But here's the kicker. Not every dead creature becomes a fossil. In fact, most of them just decompose or get eaten by other animals. Fossilization requires specific conditions, like rapid burial in sediment, lack of oxygen, and the right kind of minerals to prevent decay. So, when we find fossils, it's like finding a rare treasure that gives us clues about life on Earth millions of years ago. These clues are especially important for understanding human evolution because they help scientists piece together how our ancestors lived, moved, and adapted over time. Fossils matter because they act as the backbone of paleontology, the study of ancient life. They provide direct evidence of what species existed in different periods of Earth's history, allowing scientists to map out evolutionary timelines. For example, finding a fossilized jawbone with unique dental patterns can tell us about an early hominin's diet and how it might have evolved from earlier primates. These discoveries help us understand not just who we are today, but also how we got here, like a long, winding road of biological innovation. In the context of human evolution, fossils are like puzzle pieces that fit together to create a bigger picture. They show us when and where our ancestors lived, what they looked like, and even how they interacted with their environment. For instance, the discovery of 700,000-year-old fossils has challenged previous assumptions about human ancestry, revealing new branches in the family tree that we never knew existed. These findings are not just academic. They help us understand our place in the natural world and the incredible journey that led to modern humans. So next time you see a fossil, think of it as a message from the past. It's a reminder that life on Earth is full of surprises and that every discovery brings us closer to understanding our shared history. Whether it's a tiny shell or a massive dinosaur bone, each fossil tells a story, one that connects us to the ancient world in ways we can only begin to imagine. Imagine standing in a remote corner of East Africa where the sun beats down like it's trying to melt the very ground beneath your feet. This is where the fossils were discovered, nestled within the dusty layers of sediment that have been quietly preserving secrets for over 700,000 years. The location isn't just any random spot on a map. It's a place known as the Great Rift Valley, a geological marvel that has long been a hotspot for paleontological discoveries. This area is like nature's own time capsule, with its unique combination of volcanic activity and ancient river systems creating the perfect conditions for fossils to form and remain intact over millennia. The age of these fossils is mind-blowing, over 700,000 years old. To put that into perspective, imagine if you were born in the year 1950. These fossils would be like your great-great-great-grandparents. They've been sitting there, untouched by time, waiting for scientists to uncover their story. What makes this discovery even more incredible is that it predates many of the previously known hominin species, which means we're looking at a piece of human evolution that was once thought to be missing from the puzzle. This location has become a crucial link in understanding how early humans evolved and adapted over such an extended period. What makes this site so significant is its role as a crossroads for ancient ecosystems. The area around the discovery site was once home to a diverse range of flora and fauna, including large mammals like elephants and hippos, which helped shape the environment in ways that influenced early hominins. By studying the surrounding geology and sediment layers, scientists can piece together not just the story of these fossils, but also the broader environmental context in which they lived. This location is more than just a place where bones were found. It's a window into the past, offering insights into how our ancestors interacted with their world and how that interaction shaped the course of human evolution. The significance of this find extends beyond its age or location. It challenges existing theories about when and how early hominins began to walk upright. The fossils discovered here show clear signs of bipedalism, which is a key milestone in human evolution. This discovery has forced scientists to rethink the timeline of our evolutionary journey, suggesting that some of our earliest ancestors may have developed certain traits much earlier than previously believed. It's like finding an old map that reveals a different route to the same destination, changing how we navigate the story of human history. In addition to their age and location, these fossils are also remarkable for their preservation. Unlike many other fossil sites where bones can be fragmented or eroded over time, this site has provided scientists with nearly complete skeletons, allowing for a more accurate reconstruction of what these early hominins looked like. This level of detail is rare and invaluable, offering a glimpse into the physical characteristics that define these ancient beings. It's as if we've been handed a detailed blueprint of our evolutionary ancestors, giving us the chance to see how they moved, ate, and lived in their world. Okay, so you thought you knew how humans evolved, right? Well, these 700,000-year-old fossils are like the ultimate spoilers in a long-running TV series. They've been shaking up the entire narrative of human evolution, making scientists go, wait, did we get this all wrong? Imagine if your favorite superhero had a secret identity that wasn't what you thought. This is kind of like that, but with bones and ancient hominins. For years, the story went something like, early humans evolved in Africa, then spread out to other parts of the world. But these fossils are throwing a curveball into that narrative. They suggest that maybe our ancestors weren't as linear or straightforward as we thought. Think of it like a family tree with unexpected branches, some of which might have been growing in places you never imagined. These fossils are forcing scientists to reconsider the timeline and geography of human evolution. If these ancient hominins were around so long ago, where did they live? How did they interact with other species? And most importantly, what does this mean for our understanding of who we are as a species? It's like finding out your great-grandparents had a secret life in another country. Big changes in the family tree. One of the biggest questions these fossils raise is about the out-of-Africa theory. This idea suggests that all modern humans originated from a single group in Africa and then spread to other parts of the world. But if these fossils show evidence of human-like species living outside Africa much earlier than previously thought, it could mean that our story isn't as simple as one big migration. Scientists are now exploring new possibilities, like the idea that multiple hominin species might have coexisted and even interbred. It's like discovering that your favorite band had a side project with another group you never knew about. Unexpected collaborations that changed everything. These fossils are making us rethink not just where we came from, but how we evolved together as a species. Imagine if you found a book that told a completely different story about your family tree. That's what this discovery feels like, except instead of a book, it's fossils that are over 700,000 years old. These ancient bones have thrown the entire timeline of human evolution into chaos, like someone accidentally hit shuffle on history's playlist, and now we're all trying to figure out where we ended up. Previously, scientists thought our ancestors were walking upright and using tools much later than this, like way after the Ice Age. But these fossils suggest that some of our earliest relatives were already doing those things hundreds of thousands of years earlier than we ever imagined. This isn't just a minor tweak to the timeline. It's like finding out your great-grandma was actually a rock star instead of a librarian. The implications are huge. Tool use, which we once thought was a late-game move in human evolution, is now being linked to much older species. That means our ancestors were not only walking on two legs, but also figuring out how to make and use tools long before we ever thought they could. It's like discovering that your favorite superhero had a secret life as a librarian who also moonlighted as a master craftsman. Bipedalism, the act of walking on two legs, was once considered one of the first major steps in human evolution. But now, with these fossils, we're seeing that this milestone might have happened even earlier than previously believed. It's like finding out your favorite childhood toy wasn't just a simple plastic item, but actually had hidden compartments and secret functions you never knew about. These ancient hominins were not only standing on two legs, but also doing it in ways that suggest they were adapting to their environments with surprising sophistication. This discovery is shaking up the entire narrative of human evolution, much like a reality TV show where everyone's favorite contestant gets disqualified mid-episode. Scientists are now rethinking everything from when our ancestors first left Africa to how different species interacted and evolved over time. It's as if we've been handed a new map of history, and suddenly all the landmarks look different. The old timeline is being rewritten like a script that got a major rewrite in the middle of filming. So what does this mean for our understanding of human evolution? Well, it means we're not just looking at a linear path from apes to humans, but rather a more complex and interconnected web of species and behaviors. These fossils are like time capsules that have opened up a new chapter in our story, one where the timeline is longer, the characters are more diverse, and the plot twists are even more exciting than we ever thought possible.